To bring dead land back to life, Ricardo Morno starts by making charcoal and then he buries it, on purpose. Where a farmer might see waste, he sees the foundation of a farm. The place is Huehuetenango, in Guatemala's western highlands, a wall of steep, folded mountains that has been farmed hard for generations. From a distance it looks green. Up close, it's bleeding. On the worst slopes, every heavy rain carries the topsoil downhill dozens of tons per hectare, per year. Gone, the land isn't just poor. It's being physically dismantled, one storm at a time. Here's the question this whole story chases. Can you rebuild that soil fast enough and cheaply enough that a family actually earns more than they did farming the old way? And when someone claims they've done it, does the proof survive a hard look? The obvious fix is the one you'd reach for first: chemical fertilizer. Pour in nitrogen, force a crop out of exhausted ground. It works for a season. But bagged fertilizer is expensive, and it's imported, and its price swings with a global market. A Highland farmer can't see and can't control. Buy it every year and you're renting your own harvest from someone else. Worse, it does nothing for the underlying problem. Feed the plant, ignore the soil, and the ground keeps thinning and washing away beneath you. You're fertilizing a hillside that is quietly disappearing. This is where Ricardo Morno comes in, an agronomist working with local Mayan communities. He leads a project called Terra, Nuova, New Earth, with a deliberately audacious target: restore 500 hectares of degraded highland to productive farmland within 5 years. And he refuses to do it with a single silver bullet. His bet is that 3 ordinary things combined become something the highland has never had. The first is that buried charcoal. It's called biochar. You burn crop waste and wood slowly, starved of oxygen, so instead of turning to ash it turns to a stable, sponge-like carbon. Grind it up, work it into the field, and it stays there for decades. Under a microscope, biochar is almost all holes, a vast internal surface that grips water and nutrients, instead of letting them wash straight through. In sandy, beaten-down highland soil, that's the difference between a shower feeding the crop and a shower stealing the field. The idea isn't new. Centuries ago, peoples of the Amazon built dark, absurdly fertile soils. This way soils still growing crops today. Ricardo is borrowing an old answer to a modern collapse. The second ingredient is even older, and it's already here. It's the milpa, the indigenous system of growing maize, beans, and squash together in one plot. Each plant does a job. The maize gives the beans a pole to climb. The beans pull nitrogen from the air and feed it back into the ground. The squash sprawls low, shading the earth, holding moisture, smothering weeds. Grown together on a slope, that living cover does something a bare field of pure maize never can. It breaks the force of the rain and pins the soil in place. The milpa isn't just food. It's erosion control that you can eat. But Ricardo learned the hard way that better soil and better technique are not enough, because the real reason a poor farmer keeps doing the destructive thing is rarely ignorance. It's money and the lack of it. Making biochar takes labor before it pays anything back. Diversifying a plot means a leaner first season. A family living on the edge cannot afford to invest in next year if it means going hungry this one. So the third ingredient isn't agricultural at all. It's a community-managed microcredit, funds small loans, decided and repaid within the village itself, that bridge the gap between the work and the reward. That's the whole thesis, and it's why the pieces only work together. The credit buys the time. The milpa protects the soil. The biochar rebuilds it. Pull out anyone, and Ricardo believes the other two quietly fail. Which brings us back to the hard part of the question. It's a beautiful theory. But does it actually beat the old way, in numbers you can trust? To find out, Terra Nuova doesn't just farm, it measures. Restored plots are tracked against conventional ones next door, same slope, same rain, so the comparison is honest rather than hopeful. The early erosion figures are the most striking. On the covered, biochar-treated plots, the soil washing away drops sharply, the difference between a hillside slowly dissolving and one that is finally staying put. On income, the picture is more promising than proven. Households that diversify beyond a single maize crop and stop buying fertilizer they can't afford report earning more and spending less, but on small plots over just a few seasons. And this is where the calm, curious mind has to stay honest. A handful of plots over a few years is a signal, not a verdict. Rebuilt soil takes time. 500 hectares is a long way from a few demonstration fields. There are real ways this could stumble. If the credit fund sours, the whole engine stalls. If restoration can't move faster than the labor and the land available, 5 years becomes 10. The claim isn't wrong, it's simply not yet finished proving itself. But here is what the evidence already suggests, and it's not small. The pieces are cheap, they're local, and they're mostly things. The Highlands already have old knowledge, crop waste, and neighbors willing to lend to neighbors. That's what makes it worth watching. Not because it's guaranteed, but because if the erosion numbers hold as the plots scale, this isn't a project you fly in and impose. It's a method a village can run on its own and teach the next one. 500 hectares of new earth in 5 years is a bold promise, and Ricardo Morno hasn't kept it yet. But he's doing the rarer, harder thing, measuring honestly whether buried charcoal, old corn, and small loans can genuinely outfarm the way that's failing. If you want the full breakdown, the erosion measurements, the income figures, and the honest caveats behind them, I've put it all in the link below. Because a hopeful story is only worth telling if you can also show your work.